differential equations by separating the variables. For a differential equations constitutes of functions of x and y. The variables x and y can be separated by rearranging in the form of this. One side will be in the form of y, while the other side is in the functions of x. To solve these differential equations, you can do direct integrations of the functions after you have separated the variables. Let us try an example to apply the principles. You are asked to solve the differential equation here. You observe there is dy dx in the functions. Your ultimate goal is to reduce this dy dx to become an y function. However, you observe that these differential functions constitute of two variables which are x and y. This makes it difficult to be integrated directly unless you are able to separate the two variables x and y. To do so, copy down the functions here. Try to move x to one side while the y to the other side. This can be done by moving these functions to the other side as a divisions and moving the x to the other side as a divisions. Now your x is on one side and your y is on another side. Move your dx to the side constitute of the x functions. This gives you these functions. Next, you need to do the direct integrations for the both sides. To integrate this, let u equals to the y squared minus 1. Differentiate u over dy, you will get 2y dy. Rewrite the function here into this, where 2 multiplied 2 will be equals to 4. Bring out the y to the dy, which gives you y dy. Based on the u and du here, you may replace the value here. This will give you integrations of 2 per u du. From the function here, after integrations, you will get 2 ln u and ln x, which is derived from the 1 per x and plus a constant c. Substitute back the y squared minus 1 into the u, you will get this. Rearrange the functions by moving the ln x to the other side, it becomes a negative ln x. Based on the principles of the log, the 2 here can be transformed into the power of the functions here. The relationship between the two ln here can be rewritten in the form of this divided by x. With that, you know that the ln of these functions will be equals to c. If you get rid of the ln here, this will become e power of c. And this will be your final solution. Let us try another example. Given the functions d theta dt is this, and the relevant value are given as t equals to 0 when theta is equals to 0. You will see an differential function here. Your ultimate goal is to integrate this to become a functions of theta. And you also see there are two variables. You should try to separate the variables so that you can solve the differential equations. Write down the functions here. This can be rewritten in this form, where e power of 3t minus 2 data can be rewritten in the form of the power of 2e. Move the data to the other side while remaining the t on this side. Remain the d data here and dt will be moved to the other side. This will give you these equations. Now the two variables are separated to the left and right. You may integrate both sides. After integrations, you get this. It is given that t equals to 0 when data equals to 0. Substitute the relevant value into the function here for you to determine the constant c. When data and t equals to 0, e power of 0 will be equals to 1. Same goes to the other side. With that, you are able to solve the c equals to -1/6. Substitute the c into the equations after you integrate. You will get this. Rearrange the equations, you will obtain this. And this will be your solutions for the differential equations. Let us look at another example here. The differential equations is given here, and it is known that it passed through a point of 0 and 1. For the function here, there is a dy dx. Your ultimate goal is to reduce this into a y function. And you also see it constitutes of two variables. To solve this, you will need to separate the two variables x and y in different sides. First, write down the functions. Separate them into the variables. Move the y to the other side, it becomes 1/y. Move the functions of x to the other side, it becomes this. Move the dx to the other side, it becomes dx here. Now the two variables has been separated, left and right. You can integrate both sides in order for you to obtain the solutions. This term can be integrated, but in order to integrate this, you need to do some substitutions. Substitute u as the functions of y plus x squared. If you differentiate this u, you will get 2x dx. By looking at the function here, it only constitutes a dx and x. For you to transform this x dx into a du, you need another factors of 2 in front of it. With that, you may create a factor of 2 by creating 2 divided by 2, which is equals to 1, which ultimately do not alter the functions here. Now you have 2x dx, which can be substituted by du, and the function here can be substituted by the u here. This gives you a new functions here. After integrations, you will get 1/2 ln u plus c. This function is in the form of u. You will need to substitute back these functions into the u here, which give you this. With that, integrating these functions, you get ln y, and integrating these functions, you get this as calculated from the calculation step here. Now you have an unknown c here. It is given the coordinate of 0 and 1. You may substitute the 1 and 0 into the functions here. Ln 1 will be equals to 0. And when you substitute 0 here, it becomes ln 1. And it will eventually become 0 as well. With that, if you solve the function here, you know the c is actually equals to 0. That means there is no constant behind the solutions. With that, rewrite the functions and eliminate the c. Based on the laws of log, the 1/2 here can become the power here, which if you remove the log, you will get these functions. And this will be your final solutions for these questions.